2.5 million light years away, there's an entire galaxy drifting toward us. It's called Andromeda, and it's about twice the size of our own Milky Way. Picture 1 trillion suns, more planets than we could ever count, and mysteries we're only beginning to imagine. What kinds of worlds might be out there? What stories have unfolded in that distant place? And someday, far in the future, when Andromeda and our galaxy finally meet, what will that look like? Tonight, we're going on a journey together. We'll drift slowly through Andromeda's glowing spiral arms, past nurseries where stars are being born, through ancient graveyards where they've passed away, and near black holes where even time gets a little weird. So get comfortable. Let's explore this beautiful galaxy together. Leaving Earth behind. Our journey starts with one last look at home. Earth, that little blue marble, slowly fading into the darkness behind us. As we move beyond our solar system, our planet gets smaller and smaller until it's just another point of light among countless others. From here, Earth isn't continents and oceans anymore. It's not cities or forests. It's just a fragile jewel hanging in the black. You can see clouds swirling slowly, oceans catching the sunlight. And then, as we drift farther away, it becomes impossible to tell, apart from all the other stars around it. That tiny dot has held everything humans have ever known. Every story, every dream, every moment of history. And now, it's quietly slipping away behind us. We pass Mars with its rusty deserts and dust storms. Then Jupiter appears, those massive swirling storms, big enough to swallow Earth completely. Its moons trail behind like a little solar system of their own. Saturn glimmers next, those delicate golden rings stretching across hundreds of thousands of kilometers, yet looking as fragile as smoke from this distance. Each planet watches silently as we leave, like old friends waving goodbye from the edge of everything familiar. Soon, even the sun starts to shrink. It's no longer that blinding presence in the sky, just a brilliant star among countless others. The warmth of home falls away as we reach the outer edges, the Kuiper Belt, where icy fragments drift in frozen silence. Pluto appears briefly, distant and lonely, then vanishes back into shadow. Beyond it lies the Oort cloud, a vast shell of icy debris that might stretch almost a full light year from the sun. Out here, sunlight is just a memory, as faint as moonlight on still water. The emptiness grows deeper, the silence thickens, and you start to feel just how big this journey really is. Even our fastest spacecraft would take tens of thousands of years to reach the nearest stars. But tonight, we're moving beyond the edge of our solar system in moments, carried by imagination. With each passing mile, perspective shifts. Our solar system, which seems so vast, has become just a tiny oasis in the desert of space. Earth is now invisible. The sun is just a golden spark among billions. But instead of loneliness, there's wonder. For the first time, we can see our home as it truly is. One small flicker of light on an infinite canvas. As we leave Earth behind, we carry its stories with us. The Andromeda Galaxy waits far ahead, its spiral arms slowly turning. But before we reach it, we need to let go of the familiar. Tonight, Earth has become what it always was, one companion among countless others in an endless cosmic sea. And now we're sailing beyond it, into the mystery. The frozen frontier. Ancient chunks of rock and ice drift in silence out here. These are relics that have been floating unchanged for billions of years. We're slipping past Pluto now, heading toward the frozen frontier of the Oort cloud. The Kuiper belt circles the sun like a ghostly halo, stretching from just beyond Neptune to nearly 50 times farther than Earth's orbit. Billions of small icy worlds wander here, fragments left over from when our solar system was born. They're like time capsules, each one preserving the chemistry of a younger universe. Pluto greets us as we cross this realm. It used to be called the 9th planet, though now it's classified as a dwarf world. Sunlight takes more than 5 hours to reach here, so everything glows with just the faintest light. Its surface is strange and beautiful. Nitrogen ice plains, frozen mountains, dark valleys carved into the ice. Charon, Pluto's large moon, orbits so close that together they almost act like a double planet, locked in an eternal dance at the very edge of everything we know. Deeper into the Kuiper belt, there are countless other dwarf planets drifting in shadow. Eris, Haumea, Makemake, each one unique, each with its own moons and secrets. Their surfaces shimmer with frozen methane and water ice, painted red and brown by cosmic rays over billions of years. Sunlight is weak and distant here, but the cold silence somehow feels alive with hidden stories. Between these frozen worlds, smaller objects tumble endlessly. Comet nuclei, chunks of rock and ice. Every once in a while, one falls inward toward the warmth of the inner solar system. When it does, its icy shell begins to glow, creating those beautiful tails that streak across Earth's night sky. Every comet we've ever seen came from this very frontier. The stillness out here is profound. Imagine floating in endless black, where you could drift for millions of miles without bumping into anything. Yet even in this emptiness, the Kuiper belt quietly shapes our solar system. Its gravity nudges comets toward the sun. Its icy bodies preserve the building blocks that once formed planets. Farther still, the Kuiper belt begins to thin out, giving way to something even more mysterious. The Oort cloud. This spherical shell of icy debris stretches almost a full light year into space, marking the sun's farthest reach. No spacecraft will ever cross it in our lifetimes, but this is where our solar system truly ends, blending into the sea between stars. As we drift outward through this frozen expanse, Pluto and its companions fade into shadow. The faint warmth of the sun disappears, replaced by the infinite dark between stars. We're leaving behind the last outposts of home, stepping beyond the solar system's icy walls into something much, much bigger. Ahead lies interstellar space, and far across that cosmic ocean, Andromeda is waiting. Between stars, there's almost nothing. It's an ocean of near emptiness. But even in this vast darkness, invisible forces are at work, quietly shaping galaxies and worlds. Out here, beyond the reach of our sun's warmth, all the familiar landmarks are gone. No planets orbit nearby, no belts of comets or asteroids to pass through. The distances just stretch and stretch, each mile carrying us deeper into a realm where silence is almost absolute. If you could scoop up a cubic meter of space out here, it might contain only a handful of atoms, fewer than the air that brushes your skin on the quietest night on Earth. And yet, the void isn't really empty. Dark matter weaves through this space in invisible threads, a hidden architecture that binds galaxies together. We can't see it, but we can feel its gravity gently tugging on stars, curving the paths of galaxies across billions of light years. It's like the scaffolding of the universe, the invisible frame that everything else hangs on. Without it, stars would never have gathered into clusters, and galaxies like Andromeda would never have taken shape. As we drift deeper into the night between stars, the nearest star, Proxima Centauri, is already far behind us, just a tiny ember fading into nothing. Out here, the distances to other stars are measured in light years. Even light, the fastest thing in the universe, takes years to cross these gulfs. Stars don't look like burning spheres anymore from this distance. They're just cold, steady points, each one separated from the next by unimaginable emptiness. But the darkness breathes with invisible energy. Cosmic rays stream silently through the void, charged particles born in distant supernova explosions, racing close to the speed of light. They pass unseen, occasionally striking planets and leaving faint traces in atmospheres. Each particle carries the memory of a violent birth, a reminder that even in this deep stillness, the universe is humming with energy. There's also the faint afterglow of the Big Bang itself out here. The cosmic microwave background, ancient radiation stretched thin by the universe's expansion, still fills every corner of reality with a soft hum. It's the oldest light in existence, left over from when the cosmos first became transparent almost 14 billion years ago. Even here, in the dark gulf between stars, it lingers like a quiet echo from the very beginning. The silence isn't suffocating though, it's vast and contemplative. If Earth were placed here, the night sky would be stripped of stars. The Milky Way wouldn't form that luminous band across the heavens. The sky would just be black. In that kind of solitude, maybe we'd never imagine how vast the universe really is. But for us, this emptiness isn't an ending, it's a threshold. Beyond this interstellar night, Andromeda's light is calling faintly across the gulf, its spiral arms waiting for us. And so, guided by invisible forces and endless curiosity, we press forward into the ocean of darkness toward the promise of another galaxy, the local void. We're entering a realm so empty it almost doesn't feel real. Out here, a single atom might float alone in a space the size of a room, yet even here, that invisible scaffolding of dark matter is holding everything together. The local void stretches across hundreds of millions of light years, a vast chasm in the cosmic web where galaxies are rare and isolation runs deep. Unlike the bright clusters and threads that connect most of the universe, this region is almost pure nothingness. If Earth were placed here, our night sky would be completely stripped bare. No Milky Way, no Andromeda. Just black space broken by the faintest pinpricks of distant galaxies shimmering at the very edge of what we could see. To drift through this void is to encounter a silence deeper than imagination. Not the silence of an empty room or a forest at midnight, but the silence of true absence. No stars nearby to warm planets. No gas clouds giving birth to new suns. No spiral arms weaving across the dark. Just a thin trace of matter scattered like dust on an endless plain. Yet even here, the universe isn't completely lifeless. Invisible rivers of dark matter thread through the void, their gravitational pull shaping everything we see on the largest scales. We can't touch them or see them, but they're undeniably there, bending the paths of galaxies, sculpting the flow of cosmic time, weaving hidden bridges between light and shadow. Without this scaffolding, galaxies like Andromeda and the Milky Way could never exist. Among the emptiness, there are wanderers too, rogue planets that have been flung from their home systems, drifting forever without a sun. Their surfaces are frozen solid, blanketed in eternal night. But beneath those icy crusts, warmth from radioactive decay might be keeping hidden oceans alive. In those underground seas, life could be quietly persisting, entire ecosystems evolving in complete darkness, cut off from starlight entirely. Every so often, there are tidal remnants passing through, streams of stars stretched thin from galaxies that were torn apart by ancient collisions. These rivers of light are faint and ghostly, reminders that even in emptiness, history leaves its mark. They whisper stories of galaxies that were consumed and reshaped, of cosmic violence that played out over billions of years. To some people, the void might feel terrifying. To others, it's strangely peaceful. Imagine floating here, surrounded not by brightness, but by endless stillness. Time itself feels stretched, unhurried. Without the busy light of stars, your mind is free to drift, to wonder, to just breathe. The void becomes not absence, but space for reflection, an infinite pause in the cosmic symphony. And yet our journey doesn't end here. Beyond the local void, galaxies start gathering again, clustered into huge walls and filaments. Andromeda is turning slowly ahead of us now, its spiral arms glimmering faintly across the gulf. The silence of the void begins to lift, giving way to the promise of new light. We keep moving forward, leaving the emptiness behind, carrying with us this quiet reminder. Even in absence, the universe holds form, balance, and hidden wonder. Andromeda's halo. Far ahead, faint smudges of light start to shimmer. It's the halo surrounding Andromeda, a diffuse glow made of ancient stars and ghostly gas. This marks the boundary of a new world. We're not at the galaxy proper yet, not at those brilliant spiral arms. This is the outskirts, a vast ethereal veil stretching for hundreds of thousands of light years. The halo is a realm of quiet age, where stars are living out their final chapters as faint embers compared to the youthful brilliance within the galaxy's disk. To see it is like glimpsing Andromeda's shadow, a faint glow whispering that we're getting close to something immense. As we drift nearer, the halo reveals its true scale. It's far larger than the bright spiral core we see from Earth. Astronomers believe Andromeda's halo extends more than 1 million light years in every direction, so wide that it actually brushes against the edges of our own Milky Way's outer halo. The two galaxies are already touching, not in stars, but in the delicate embrace of their gaseous shrouds. The gas in Andromeda's halo is incredibly thin, more tenuous than the best vacuums we can create on Earth. But stretched across such vast distances, it contains the mass of billions of suns. We can't see it with our eyes, but it glows faintly in ultraviolet light, revealed by the way it absorbs and scatters radiation from distant background galaxies. It's both a shroud and a reservoir, a cosmic ocean feeding the spiral arms within, replenishing them with raw material for new generations of stars. Scattered throughout this halo are globular clusters, dense spheres of ancient stars bound together by gravity. Some are nearly as old as the universe itself, relics from the very beginning of galaxy formation. Each cluster contains hundreds of thousands of suns, orbiting in tight patterns, like bees circling a hive. For billions of years, they've drifted out here, far from the galaxy's busy core, silent witnesses to Andromeda's growth and change. Among these clusters and clouds, dark matter dominates. Though invisible, it outweighs all the visible stars and gas by about 5 times, forming the invisible skeleton that gives Andromeda its shape. The stars we see are only the surface, the visible frosting on a structure whose true form is hidden in shadow. The halo is also home to orphans, stars that have been flung here by ancient collisions and gravitational encounters. They drift alone now, stripped from their galaxies long ago, bound only by Andromeda's gravity. Their light is faint, stretched thin across distance, but each one tells a story of survival, a reminder that galaxies are built as much by destruction as by creation. As we gaze across this shimmering veil, we realize we're crossing a threshold. Beyond lies the true body of Andromeda, a trillion suns arranged in those spiraling arms. But here at the edge, in this faint and ghostly light, we first sense the immensity of what awaits. The halo is Andromeda's breath, its quiet outer skin, and our passage through it marks the beginning of a new chapter in our journey. A trillion suns. As we draw closer, Andromeda unfolds before us like a vast island in space, its spiral arms stretched for hundreds of thousands of light years, glittering with a trillion suns. No longer just a faint smudge in the night sky, the galaxy now fills our view. An immense, luminous structure, a spiral city of stars turning slowly in the silence of space. Each arm curves outward like a cosmic tide, threaded with star clusters, glowing nebulae, and rivers of dust. It's a sight that goes beyond imagination, a vision of scale that makes everything we know feel small. Each speck of light within this whirlpool isn't just a sparkle, it's a star, and many of them are orbited by their own planets and moons. Imagine a trillion suns, each with its own system, each with a story waiting to be told. Some burn as hot blue giants, living fast and dying young. Others glow as dim red dwarfs, steady and patient, destined to shine for trillions of years into the future. Scattered among them are golden stars like our own sun, quietly creating the conditions that might allow life to flourish on unseen worlds. The spiral arms themselves aren't fixed structures, they're density waves, patterns of compression sweeping through the galaxy like ripples on water. Stars flow into these crowded lanes where gas and dust gather and ignite, and new generations of suns are born. The arms are both pathways and nurseries, channels where the galaxy endlessly renews itself. At the center, there's a galactic bulge glowing like a golden furnace, brighter and denser than the outskirts. Here, billions of ancient stars cluster tightly around a hidden monster, a supermassive black hole, millions of times the mass of our sun. It anchors the entire galaxy, shaping its spiral arms, holding together the trillion stars that orbit its invisible core. Dust lanes thread through the arms like dark veins, carving streaks across the glowing disk. They're not empty voids, they're regions thick with raw material, hydrogen, and heavier elements that will eventually collapse into future stars and worlds. Nearby, glowing nebulae mark the places where this process is already happening. Great clouds lit from within by newborn suns. Their colors, crimson, sapphire, violet, are like lanterns scattered across the spiral, reminders that the galaxy is alive with creation. And beyond the crowded arms, globular clusters drift in quiet arcs around the galaxy, ancient and enduring. Each cluster contains hundreds of thousands of stars, relics from the earliest days of Andromeda's formation. They shine like distant watchfires at the edge of this galactic ocean. The scale is staggering. To cross Andromeda at the speed of our fastest spacecraft would take far, far longer than the entire age of the universe. And yet as we drift closer, the sheer immensity feels less overwhelming and more serene, an endless ocean of light, timeless and calm. Here among the trillion suns, questions naturally arise. How many of these stars cradle life? How many civilizations might be gazing outward right now, wondering the same things we are? For now, the galaxy keeps its secrets, but we're within its ocean now, drifting through it, and the journey has only just begun. The spiral dance. Andromeda's arms rotate with slow majesty, carrying with them clusters of stars, clouds of gas, and perhaps even planets with oceans like our own. From here, the arms aren't rigid structures at all. They're graceful waves of density sweeping outward from the galaxy's heart. They don't move like solid wheels. They flow like ocean tides, slowly and endlessly, each spiral carrying the materials of both birth and death. It's a dance measured not in years, but in millions of years. Motion so vast and deliberate that to our eyes, it appears frozen. Yet across the ages, the galaxy is always moving, its arms twisting and unfurling through the cosmos. Within these arms, star formation is thriving. Gas clouds collapse under their own gravity, igniting into clusters of new suns. Some blaze as bright giants, others glow as faint dwarfs. Together, they light the arms from within, creating glowing arcs that ripple through space like lanterns strung across an infinite night. The spiral arms aren't just rivers of stars, they're nurseries, engines of creation, giving birth to countless new worlds. Dark lanes of dust thread through the spiral, veiling parts of the galaxy in shadow. These clouds are cold and quiet, but within them lie the seeds of future suns. From Earth, these dust lanes look like dark streaks cutting through Andromeda's bright disk. But from here, they're massive structures, billowing curtains of matter stretching thousands of light years, sculpted by gravity and starlight. Somewhere in these arms, there might be planets with oceans, continents, and skies not so different from our own. Worlds bathed in double sunsets, or orbiting red dwarfs where twilight lasts forever. The spiral arms might carry entire civilizations hidden beyond our reach, their histories unfolding quietly as their stars glide through the galaxy's embrace. To imagine them is to feel both awe and humility, tiny sparks of possibility scattered through the arms like grains of sand on a cosmic shore. For all their beauty, the spiral arms are also temporary. They're patterns, not permanent fixtures. As stars orbit the galactic center, they drift in and out of these arms, gathering for a while, then spreading outward again. It's like a traffic jam on a highway. Cars bunch together, then disperse. The arms remain, but the stars within them are forever changing. Even our own sun, far away in the Milky Way, has probably passed through spiral arms many times, each crossing shaping Earth's history in ways we're only beginning to understand. To drift along Andromeda's spirals is to feel the motion of time itself, slow, steady, eternal. There the galaxy's heartbeat, pulsing with cycles of creation and destruction, binding its trillion suns into a pattern of quiet majesty. As we continue inward, the arms begin to tighten, their graceful arcs leading us closer and closer to Andromeda's luminous heart. The dance continues, and we follow its rhythm deeper into the galaxy's embrace. Stellar nurseries. In vast clouds of hydrogen, gravity works its magic, collapsing gas into blazing new suns. These regions glow in pink and violet, painting Andromeda with luminous brushstrokes. From a distance, These nurseries look like delicate wisps of color suspended against the blackness of space. But up close, they're immense, spanning dozens of light years. Each one is a workshop of creation where countless stars are being born, hidden deep inside swirling cocoons of gas and dust. Some stars are tiny and faint, destined to shine for trillions of years. Others grow massive, burning with such intensity that they'll exhaust themselves in just a few million years, leaving behind remnants far stranger than the stars themselves. The process begins quietly. In the coldest pockets of these clouds, gravity pulls atoms closer together, forming dense knots. As they collapse, they heat up. Eventually, deep in their cores, nuclear fusion ignites. In that moment, a star is born. Its light pushes outward, illuminating the surrounding gas and sculpting it into glowing shapes: pink, violet, and blue. These glowing regions are called emission nebulae, cosmic canvases where physics and beauty become one. Some stellar nurseries in Andromeda are so vast they could contain our entire solar system thousands of times over. Inside, newborn stars emerge in clusters, bound together by gravity. Many will remain siblings for millions of years before eventually drifting apart. Our own sun probably formed in a cluster like this, surrounded by thousands of stellar brothers and sisters that are now scattered across the Milky Way, too distant to identify. In these nurseries, we glimpse echoes of our own beginning. The most massive stars born here shine with light so intense that they carve away their surroundings. Their radiation and stellar winds push back the clouds, hollowing out great caverns and sculpting towers and pillars of dust. These structures, sometimes stretching for light years, look like cosmic sculptures, spires and arches glowing softly against the galactic night. Yet their beauty is temporary. Over time, the very stars that created them will tear them apart, scattering their fragments back into space. Among this creative chaos, the seeds of future worlds take shape. The leftover dust and gas surrounding young stars often flatten into spinning disks. Within these disks, tiny grains collide and stick together, slowly building into planets, moons, and asteroids. Here, in these swirling rings of matter, the blueprints for new solar systems are drawn. Perhaps somewhere deep within Andromeda's arms, a planet like Earth is forming right now. A small, blue world destined to cradle life beneath alien skies. To witness these nurseries is to see the galaxy renewing itself. Stars are born, stars die, and in their deaths, heavier elements, carbon, oxygen, iron, scatter back into space, enriching the clouds and setting the stage for another generation. It's a cycle without end, a cosmic rhythm older than any civilization, endlessly repeating. As we drift away from these glowing nebulae, the arms of Andromeda continue to sweep outward. Behind us, the nurseries flicker like lanterns in the dark, reminding us that even in the coldest reaches of the cosmos, creation never stops. Blue giants. Some stars here burn hotter than imagination allows, glowing in fierce blue-white brilliance. They live brief but spectacular lives, destined to explode in cosmic violence. These are the blue giants, the titans of Andromeda. Compared to our sun, they're massive, tens, even hundreds of times bigger, radiating with light so powerful that a single one can outshine entire clusters of lesser stars. Their heat is so intense that their surfaces blaze at tens of thousands of degrees, giving them that signature blue-white glow. To look at them is to see pure energy made visible, the raw fire of the universe at its most extreme. But such brilliance comes at a cost. The fusion reactions that give them life consume their fuel at a staggering rate. Where a modest star like our sun will shine steadily for about 10 billion years, a blue giant might last only a few million. In cosmic terms, their lives are fleeting sparks, short, violent bursts of light before darkness. Around these stars, entire systems are transformed. Their radiation floods nearby space, stripping atmospheres from planets, igniting surrounding nebulae, and shaping the architecture of their regions. If Earth were placed in orbit around one, its atmosphere would be torn away in moments, the surface scorched beyond recognition. Yet from a distance, their glow is mesmerizing, like cosmic lighthouses shining across the galaxy's dark sea. These giants are restless and unstable. Many rotate rapidly, flinging matter into space at incredible speeds. Others swell into supergiants, their outer layers ballooning outward, trembling on the edge of collapse. Some exist in binary pairs, locked in gravitational dances with companions that strip matter from their surfaces, accelerating their already volatile lives. Their ends are inevitable and spectacular. When their cores can no longer support the crushing weight of their mass, they collapse in an instant. The result? A supernova, an explosion so powerful, it briefly outshines the entire galaxy. For weeks, the light of a dying giant can blaze brighter than 1 trillion suns, visible across intergalactic distances. The shockwaves rip through space, scattering heavy elements, iron, carbon, oxygen, across the galaxy. From these ashes, future stars, planets, and perhaps even life will one day form. Some blue giants leave behind neutron stars, so dense that a teaspoon would weigh billions of tons. Others collapse even further into black holes, invisible voids that swallow even light. In death, as in life, these giants alter their surroundings, leaving scars and legacies that shape the galaxy for billions of years. Andromeda is filled with such giants, burning now, dying now, scattering their gifts across its spiral arms. They remind us that brilliance and brevity often go hand in hand, that some of the most magnificent lights shine only for a moment. As we drift onward, the fiery glow of the blue giants fades behind us. Ahead lies a different kind of wonder, not the brief, furious lives of titans, but the long, steady glow of ancient gatherings. Globular clusters. Dense globular clusters shine like ancient cities, spheres packed with hundreds of thousands of stars where night would never truly be dark. Floating in Andromeda's halo and threading through its spiral arms, these clusters are among the oldest structures in the universe. Each one is a brilliant sphere of stars, tightly bound by gravity, glowing like a suspended lantern in the cosmic night. Some contain so many stars that if you lived within their core, the sky would never go dark. Instead, thousands of suns would blaze overhead, casting a perpetual twilight on any world lucky enough to orbit there. Globular clusters are time capsules, relics from the earliest days of galaxy formation. Most formed more than 12 billion years ago when the universe was still young and chaotic. Their stars are ancient, made almost entirely of hydrogen and helium, lacking the heavier elements forged later in massive stars. Because of this, planets are rare in globular clusters. These stellar cities probably aren't homes for Earth-like worlds, yet they remain some of the most dazzling sights the cosmos has to offer. The density within these clusters is staggering. In our neighborhood of the Milky Way, the nearest star to the Sun is more than 4 light years away. Inside a globular cluster, that distance shrinks to a fraction of a light year. Stars are packed so closely that if you stood on a planet within the core, the night sky would blaze with thousands of suns brighter than Venus appears from Earth. Every horizon would shimmer with golden light, a sky alive with constant radiance. Life in such an environment would be chaotic. Gravitational forces would constantly tug at planetary orbits, making them unpredictable. A planet's path around its star could be shifted or destroyed entirely by a close stellar encounter. Yet the beauty of these clusters lies not in habitability, but in endurance. For billions of years, they've circled their host galaxies like faithful companions, surviving cosmic collisions, galactic mergers, and the slow march of time. Some of Andromeda's clusters rival the largest we know, behemoths containing over 1 million stars. They drift at the galaxy's edge like silent guardians marking its boundaries. Others are smaller, scattered throughout the spiral arms like starry neighborhoods within the greater galactic city. As we drift past these spheres of light, we're reminded that time itself is written in the stars. Each cluster holds memories of an age long before Earth, long before the Sun. They're cities without walls, ancient yet eternal, glowing like watchfires across the vast ocean of Andromeda. Red dwarfs, the quiet guardians. Most stars in Andromeda aren't blazing giants but tiny steady embers. These red dwarfs burn quietly for trillions of years, guardians of stability in a restless cosmos. Unlike the brilliant blue giants that flare brightly and vanish quickly, red dwarfs live on timescales that stagger the imagination. They're small, often less than half the mass of our Sun, and cool, glowing in deep shades of crimson or faint orange. But what they lack in brightness, they more than make up for in endurance. Where a star like our Sun will shine for 10 billion years, a red dwarf can burn slowly for trillions, outliving not only its brighter neighbors, but perhaps even the universe as we know it. In Andromeda, as in the Milky Way, red dwarfs are by far the most common stars. For every giant or sun-like star, there are dozens of these faint embers scattered through the galaxy. To the naked eye, they're nearly invisible, their light too weak to stand out. Yet in sheer numbers, they dominate the galaxy, quietly shaping its destiny. Around many red dwarfs, planets circle in tight orbits. Because these stars are cool, their habitable zones, the regions where liquid water could exist, lie much closer than Earth is to the Sun. A world in this zone would orbit quickly, with short years and long, slow seasons. Some of these planets might even be tidally locked, with one side in perpetual daylight and the other in endless night. Yet along the twilight band between them, conditions might be just right for life to flourish. Astronomers believe that if life exists beyond Earth, many of its homes could be worlds orbiting red dwarfs. Their sheer abundance increases the odds, and their extraordinary lifespans provide time for biology to evolve and adapt. Imagine civilizations rising beneath the steady glow of a star that never changes, their history unfolding across ages while their sun burns with the patience of eternity. But red dwarfs come with challenges too. Many are active in their youth, unleashing powerful flares and radiation that can strip atmospheres from planets. Some worlds might be scorched before they ever have a chance to become habitable. Yet as these stars age, they quiet down, their fires becoming steady and calm. The oldest red dwarfs have likely been burning since the dawn of galaxies themselves, silent witnesses to cosmic history. Here in Andromeda, countless red dwarfs shine unnoticed, their faint light weaving the background fabric of the galaxy. They're not the stars we see in photographs or admire in constellations, but they're the hidden foundation the galaxy rests on. Drifting among them feels like passing through a field of quiet embers, soft glows scattered endlessly, patient and enduring. They don't dazzle, but they persist, offering stability in a universe defined by change. In their unassuming way, these quiet red dwarfs are the galaxy's most faithful guardians. Worlds beyond imagination. From molten surfaces to frozen oceans, Andromeda's planets stretch the imagination. Some might shimmer with crystal forests, while others hide oceans beneath thick ice. Each planet orbits quietly beneath its parent star, a story written in rock, metal, gas, and water. Some are scorched by the fierce light of blue giants, their surfaces like seas of magma, where rivers of lava flow endlessly. Others drift far from warmth, locked in eternal winter, their atmospheres frozen solid, their oceans sealed beneath crusts of glittering ice. The galaxy is vast enough to hold all possibilities, worlds familiar, worlds alien, and worlds we can barely imagine. Gas giants dominate many systems, great spheres of hydrogen and helium that dwarf every planet in our solar system. Their swirling bands of storms stretch for thousands of miles, while their magnetic fields shape entire miniature solar systems of moons. Some of these moons are volcanic, spewing plumes of fire into space. Others are frozen, hiding oceans beneath their icy crust, potential havens for life, shielded from the emptiness beyond. Closer to their stars, rocky planets blaze in extremes. Some are covered in reflective seas of glass, formed when meteors strike their hot surfaces. Others glisten with crystalline formations, entire landscapes of diamond and sapphire created under unimaginable pressure. Their skies might glow with colors unknown to us, green auroras from alien atmospheres, golden hazes of methane, or scarlet clouds heavy with iron dust. In cooler orbits, more temperate worlds might exist. Here, oceans of water could spread beneath calm skies, islands rising like emeralds from the blue. Continents might drift, mountains rise, weather systems swirl, an alien Earth beneath an unfamiliar sun. Perhaps forests stretch across valleys, or seas shimmer with organisms that glow in the dark. If life found a way on Earth, it may have found a way here too, quietly thriving across the galaxy. Some planets wander freely, untethered to any star. Cast out by gravitational encounters, they drift in eternal night. On their surfaces, the cold is relentless. But beneath thick crusts, geothermal heat might keep hidden oceans alive. Imagine creatures evolving in total darkness, never knowing starlight, existing in silence within worlds adrift in the void. These rogue planets remind us that life might find shelter in the most unlikely places. Across Andromeda, the diversity is staggering. With a trillion stars, there might be trillions of planets, each carrying the potential for landscapes stranger than any dream. To drift among them is to witness the cosmos's imagination at work. Each world a canvas painted by the forces of physics and chance. As we continue deeper into Andromeda's spiral arms, we leave these diverse worlds behind. Yet one thought lingers. How many of these planets hold life? How many skies shimmer above civilizations looking outward? wondering if they're alone. The galaxy keeps its secrets, but the possibilities are endless. Moons and hidden oceans. Circling distant planets are moons as varied as worlds themselves, icy shells, volcanic surfaces, and perhaps places where life finds a foothold. Across Andromeda's trillion suns, countless moons drift in orbits, both delicate and dramatic. Some are as small as mountains, little more than captured fragments of rock and ice. Others rival planets in size, their surfaces scarred by craters, valleys, and seas of frozen methane. Moons aren't mere companions, they're worlds in their own right, shaped by the gravity of the giants they circle, each carrying a unique story carved across its surface. Many moons are icy spheres, their crusts gleaming like polished mirrors beneath starlight. Beneath these frozen exteriors might lie vast oceans, hidden and warm, kept liquid by tidal forces as they flex under the pull of their parent planet. In such hidden seas, the ingredients for life could quietly mix, protected from radiation and the emptiness of space. Entire ecosystems might flourish here, unseen and untouched, their existence known only to the stars that warm them from afar. Other moons are volcanic and restless. Their surfaces are alive with eruptions, geysers of molten rock, or plumes of water vapor bursting into space. These eruptions sculpt ever-changing landscapes, reshaping valleys and mountains in cycles of destruction and renewal. From orbit, they'd appear as living worlds, fiery, unstable, yet beautiful in their constant transformation. Some moons are cloaked in thick atmospheres. Picture a pale orange sky dimly lit by a distant star, clouds drifting slowly over endless seas of methane. Winds whisper across alien lakes, shaping dunes of ice and organic compounds. These are places of strange chemistry, environments far different from Earth, yet potentially capable of harboring life adapted to their unusual conditions. There are also captured moons, wanderers from elsewhere, snared by the pull of giant planets. Their orbits are irregular, tilted, sometimes moving backward against their neighbors. These stolen worlds carry marks of violent pasts, evidence of collisions and cosmic encounters long forgotten. In their unusual paths, they remind us that the galaxy is a place of both order and chaos. Some moons might even hold atmospheres dense enough to support rain, rivers, and seas. Imagine standing on such a world gazing upward, not at a solitary sun, but at a colossal planet filling half the sky, its rings arcing like luminous bridges. Nights here would never be truly dark, always lit by the glow of the planet and its sibling moons. Such a view would humble even the most advanced beings, a constant reminder of the cosmos's scale and beauty. In Andromeda, the moons are as diverse as the stars themselves. They might harbor ice, erupt with fire, or drift in silence as frozen relics. Each one is a world of wonder, circling endlessly, part of the grand rhythm of the galaxy. As we continue our journey, we leave these moons behind, carrying the thought that even the smallest companions can hold the greatest mysteries. Diamond rain and methane seas. Exotic chemistry reigns on some alien planets where storms of diamond fall from methane skies and oceans glow faintly beneath pale suns. These are worlds that defy our earthly expectations, sculpted by physics and chemistry into landscapes as surreal as dreams. On certain gas giants deep within Andromeda, The pressures and temperatures inside their thick atmospheres reach extremes beyond imagination. Here, carbon atoms might compress into crystalline structures, forming diamonds that tumble like rain. Entire storms could fill the skies with glittering shards, falling endlessly into depths we may never see. To watch such a storm would be to see jewels descending from the heavens, an alien spectacle born of natural law. Elsewhere, seas of methane and ethane stretch across planetary surfaces, shimmering beneath hazy skies. These aren't water seas, but liquid hydrocarbons, cold, heavy, and strange. Winds ripple across them, driving waves that lap upon frozen shores. Imagine standing at their edge, watching liquid methane reflect the faint light of a distant star. The air would be dense, tinted orange or yellow, and every breath would remind you that you're in a world utterly unlike Earth. Yet in this strangeness, there's beauty, a rhythm and balance written in chemical possibility. Some of these seas might even glow faintly. Bioluminescent organisms adapted to alien chemistry could light the waters from within, painting the surface in pale blues and greens. Whether such life exists is only speculation, but the possibility lingers, a reminder that the universe creates surprises in places we once thought impossible. Above, skies are painted in hues unfamiliar to our eyes. Methane scatters light differently than Earth's nitrogen-rich air, producing skies that glow in shades of violet or rose. Clouds might form from hydrocarbons, drifting in slow, eerie shapes. Thunderstorms could unleash flashes of exotic lightning, illuminating the surface for brief, breathtaking moments. Deeper within these alien giants, chemistry grows stranger still. Layers of ammonia, water, and hydrocarbons form oceans stacked upon one another, compressed by crushing gravity. Buried far below, metallic hydrogen might churn, generating magnetic fields that stretch thousands of miles into space. These invisible forces shape auroras, vast curtains of light that shimmer above the planets, glowing in colors no human has ever seen. The diversity of these exotic worlds reminds us that Earth is only one possibility among countless others. What we call rare might be common elsewhere. What seems impossible might be natural in a galaxy as vast as Andromeda. Diamond rain from alien skies, oceans of methane reflecting pale starlight, lightning flashing across violet atmospheres. The cosmos is an artist painting with a palette far richer than we can imagine. As we drift away from these strange and beautiful planets, one thought remains. The universe isn't bound by our expectations. It's bound only by its own laws, and those laws create wonders that humble and astonish in equal measure. Binary stars and twin sunsets. In systems with twin suns, light bends and dances in unfamiliar ways. Days stretch, nights vanish, and strange ecosystems adapt to shifting skies. Binary star systems are among the most common arrangements in the galaxy. Instead of a single sun, two stars orbit each other, bound by gravity in a celestial dance. From afar, they move like partners in slow motion, circling their shared center of mass. To the worlds that orbit them, however, the presence of twin suns creates landscapes and skies unlike anything we've ever known. On some planets, the two stars rise and set together, their combined brilliance bathing the land in golden fire. Days are longer, brighter, and more intense than any on Earth. Shadows overlap, stretch, and shift in complex patterns. On other worlds, the stars orbit at different paces. One sun might rise just as the other sets, leaving the sky in near constant daylight. Imagine living on such a world. No true night, only shifting hues as one star hands its light to the next. For some planets, the orbits create cycles of extremes. When both suns align, the surface blazes in doubled light, temperatures soaring. When the stars drift apart, shadows lengthen and twilight spreads. Life here might evolve to endure sudden brightness and rapid dimming, adapting to rhythms utterly unlike Earth's steady day and night. Skies above binary worlds would be breathtaking. Two suns could glow in different colors, perhaps one a hot white star and the other a cooler red. Together, they'd paint skies with strange contrasts. Sunsets could ripple in layers of crimson and gold. Eclipses might occur often as one star passes in front of the other, casting worlds into sudden, eerie shadows. The sky would be alive with motion, a theater of light and darkness playing endlessly overhead. Moons orbiting these worlds would add another layer of complexity. Picture a night where one sun has set, leaving the other hovering low on the horizon while multiple moons drift across the sky. Their reflected light would mingle, creating patterns of silver, red, and gold, shifting canvases that never repeat. Nights would never be truly dark, but filled with pale glows and shifting shadows. Binary systems also challenge stability. The gravitational pull of two suns creates delicate orbits, and not every planet can endure. Some are flung out into the void as rogue worlds, cast adrift forever. Others remain stable, tracing graceful paths around both suns in wide orbits. Where conditions are right, such planets could be habitable, warmed by two steady fires, sustained by the delicate balance of dual light. In Andromeda, countless binary systems exist, each shaping its worlds in unique ways. To drift above such a planet is to witness the universe's imagination at play, a reminder that Earth's single sun is only one version of what a sky can be. As we leave these twin star systems behind, we carry their image with us. Rogue planets, wanderers in the dark. Some worlds drift unbound, flung from their stars. They wander the void, frozen on the surface, yet warm oceans might still flow deep beneath. These are rogue planets, cosmic nomads cast adrift by gravitational forces. No longer tethered to the warmth of a sun, they travel silently through interstellar space, without dawns or sunsets, without skies touched by starlight. From their frozen surfaces, the universe would appear as nothing more than a tapestry of distant stars, cold and unreachable. No seasons, no day, only endless night. Rogue planets are born the same way as others, within swirling disks of dust and gas around newborn stars. But instability, collisions, or the gravitational pull of larger neighbors often disrupts them. Some are hurled outward during the chaotic formation of solar systems, expelled into the void like exiles. Others are stolen by passing stars, flung into trajectories that never return. In Andromeda, where countless systems dance in complex gravitational webs, rogue planets might number in the billions. On their surfaces, the cold is beyond comprehension. Temperatures plunge hundreds of degrees below zero, freezing atmospheres into solid crusts. Landscapes might be barren plains of ice, stretching for thousands of miles under skies forever black. Volcanoes might puncture the silence, releasing faint plumes of steam before they freeze instantly in the airless dark. And yet even here is the possibility of warmth, beneath thick layers of ice and rock. Geothermal heat from radioactive elements could sustain subsurface oceans. These hidden seas might remain liquid for billions of years, sealed off from the cold vacuum above. Within them, chemistry could flourish, perhaps even life. Creatures, if they exist, would never know the stars. They'd evolve in total darkness, guided only by chemical gradients or the faint glow of hydrothermal vents. Entire biospheres could thrive undetected, hidden in the bellies of wandering worlds. Some rogue planets might even carry thick atmospheres of hydrogen that insulate heat and trap warmth from their cores. These planets could sustain surface oceans despite the absence of a star. The light in their skies wouldn't come from a sun, but from auroras sparked by magnetic fields, or from lightning ripping across storm-filled atmospheres. To an observer standing on such a surface, the night would be broken not by sunlight, but by brief flashes of alien fire. Rogue planets remind us that habitability isn't limited to the gentle glow of a star. Life, if it arises, might do so in isolation, far from warmth, finding refuge in hidden oceans and volcanic depths. They're worlds of solitude, carrying secrets across interstellar distances, drifting endlessly between galaxies. As we leave these dark wanderers behind, their image lingers. Planets lost in the black, oceans sealed beneath ice, and the quiet suggestion that even in the loneliest places, the universe might still nurture life. Their mysteries, adrift in the dark sea of Andromeda, carried silently toward eternity. The supermassive black hole. At the center waits a supermassive black hole, millions of solar masses compressed into a point. Its gravity shapes the entire galaxy's destiny. Though invisible to the eye, its influence is written everywhere. Stars whirl around it in intricate orbits, their speeds revealing the hidden presence of something vast and heavy. Clouds of gas spiral inward, heating as they fall, glowing in X-rays that pierce across space. Here in the silent heart of Andromeda, gravity reigns supreme, an unseen monarch holding an entire galaxy in its grasp. This black hole is enormous, thought to be more than 100 million times the mass of our Sun. To imagine it is to contemplate the impossible, a singularity where matter collapses into a point of infinite density, where the laws of physics as we know them break down. Around it lies the event horizon, the boundary from which no light can escape. Cross it, and time itself bends, space twists, and escape becomes forever impossible. Yet despite its fearsome nature, this black hole is also a creator. As matter falls toward it, immense energy is released. Jets of particles might stream outward at near the speed of light, shooting into intergalactic space for thousands of light years. These cosmic outbursts sculpt the galaxy around them, regulating star formation, stirring gas, and shaping the fates of billions of stars. In destruction, there's also design, a paradox that defines the heart of every great galaxy. The stars closest to Andromeda's black hole live in a dangerous dance. They orbit at blistering speeds, whipped around by gravity's pull, their paths bending sharply around the invisible void. If you stood on a planet in this region, the night sky would be overwhelming. Stars would blaze far brighter and closer than any we see from Earth, their light tangled together in a dense, glittering web. Yet always, at the very center, there'd be a perfect darkness, a hole in the sky from which nothing returns. Despite its power, the black hole doesn't devour everything. Most stars and planets in Andromeda orbit safely at distances where its gravity is no more dangerous than any other massive body. The galaxy thrives, its spiral arms filled with light and life, while the dark heart waits silently at its center. In billions of years, when Andromeda and the Milky Way merge, their central black holes will also collide. The result will be a single, even larger singularity, sending ripples of gravitational waves across the universe, a silent echo of two galaxies becoming one. For now, Andromeda's black hole remains a hidden presence, quiet and steady. It's the anchor of the galaxy, the engine of its order, and a reminder that the most powerful forces in the cosmos often lie beyond sight. As we drift away from this mysterious core, we carry the awareness that within silence and darkness, the universe holds both destruction and creation in perfect balance. Where time bends. Near this dark titan, time itself slows. Minutes for us become centuries far away, a reminder that time isn't universal but relative. This strange truth is one of Einstein's greatest revelations. Time isn't fixed but elastic, shaped by the presence of mass and energy. Near Andromeda's central black hole, space bends and curves like stretched fabric. Gravity pulls not only on matter, but on time itself, slowing its passage in ways our everyday experience can barely grasp. To drift close to this cosmic abyss is to enter a realm where seconds and hours lose their familiar meaning. Imagine hovering safely outside the black hole's event horizon. If a spacecraft were to descend closer, we'd watch its movements gradually slow. Its lights would flicker more sluggishly, its signals stretching into longer and longer wavelengths. To us, it would appear to freeze at the edge, never quite crossing the threshold. But for those inside the craft, time would seem normal. They'd move, think, and breathe, as always. Yet to them, the universe outside would be racing ahead, centuries flashing by in what feels like moments. This is the nature of relativity. Time isn't a single universal flow, but a river that bends and quickens depending on where you stand. In the grip of immense gravity, that river slows almost to stillness. Farther away, it surges forward. Both perspectives are true, both realities valid, yet they don't align. The closer you move towards the black hole, the greater the distortion becomes. This warping of time isn't confined to Andromeda's core. Even Earth experiences it, though subtly. The stronger the gravity, the slower time flows. Clocks on mountaintops run fractionally faster than those at sea level, simply because they're farther from Earth's center of mass. In everyday life, this difference is invisible. But near a black hole, the effect becomes profound. Minutes and millennia separate with startling ease. To imagine living near such a region is to picture a civilization where generations of the galaxy pass in the span of a single lifetime. Stars would be born and die in what feels like years. The galaxy would evolve while they remained unchanged, watching the cosmos transform in accelerated motion. In such a place, the meaning of time itself would shift. No longer a shared rhythm, but a local phenomenon. It's humbling to realize that time, which feels so constant to us, is in truth fragile, bendable, and tied to the fabric of space itself. And in the presence of black holes, that fabric stretches almost to breaking. As we leave the warped region near Andromeda's heart, time resumes its gentler flow. Seconds and centuries align once more, the universe returning to its familiar rhythm. But the memory lingers. That time isn't universal, that it bends with gravity, and that in the heart of the cosmos, Even time itself must bow to the power of mass and motion. Galactic cannibalism. Andromeda has grown by devouring smaller galaxies. Streams of orphaned stars still trace arcs across its halo, echoes of long-forgotten collisions. Galaxies aren't static islands of stars. They're living systems shaped by constant interaction. Gravity pulls them together, tears them apart, and blends them into new forms. Over billions of years, Andromeda has consumed countless companions, dwarf galaxies, globular clusters, and fragile streams of stars that wandered too close. Their remnants remain even now, faint ribbons of light threading through the galaxy's outer reaches, the last whispers of galaxies that once shone brightly on their own. This process, though violent in scale, isn't sudden. When two galaxies meet, stars don't collide directly. The space between them is too vast. Instead, their mutual gravity stretches and distorts them, pulling stars into long tidal streams. Gas clouds are compressed, triggering bursts of new star formation, while dark matter halos merge and reshape. Slowly, over hundreds of millions of years, the galaxies fuse. Their identities are erased, their stars absorbed into a greater whole. Andromeda's halo tells the story clearly. Observations reveal rivers of stars looping around it, stellar streams left behind by devoured companions. Each one is a scar in the galaxy's structure, evidence of past meals. Some are faint arcs, stretching across thousands of light years. Others are dense knots, remnants of cores that resisted total dissolution. Together, they paint a picture of Andromeda, not as a solitary spiral, but as a collector of worlds. Among the most striking remnants are dwarf galaxies, still in the process of being consumed. Andromeda is accompanied by dozens of smaller satellites, many destined to spiral inward and merge. For them, the end is inevitable. Their stars will be stripped, their shapes stretched thin, until nothing of their original form remains. In time, their light will join the trillion stars of Andromeda, indistinguishable from those born within its spiral arms. This cycle of destruction and renewal is central to galactic evolution. Without mergers, Andromeda wouldn't have grown so vast. Its mass, its sweeping spiral arms, its rich population of stars, all are products of this cosmic cannibalism. Even the Milky Way, our own galaxy, has grown by swallowing smaller neighbors, and in the far future, it too will merge with Andromeda, continuing the endless cycle. To imagine this process is to picture galaxies not as peaceful whirlpools of light, but as both predators and creators. Each collision reshapes the cosmos, erasing old forms and igniting new ones. What seems like destruction is also a kind of creation, the birth of something larger and more luminous. As we drift past Andromeda's halo, we see those faint streams glowing softly like cosmic fingerprints etched across the dark. They're the remnants of long-lost galaxies, survivors only in memory, their stars now bound to Andromeda's destiny. Here, in the quiet of space, we realize that even galaxies must consume to grow. It's not cruelty, but the rhythm of the universe, an endless feast where light is never lost, only remade. Stellar graveyards, white dwarfs, neutron stars, and magnetars fill Andromeda's graveyards, remnants of stars that lived and died billions of years ago. Every galaxy carries its cemeteries, silent fields of stellar remnants. Each one is the last chapter of a story once told in light. Andromeda is no different. Within its spiraling arms and dense clusters, lie the remains of stars that burned brightly, only to fade into stillness. They're not gone though, just transformed, condensed into forms stranger and denser than the stars they once were. White dwarfs are the most common of these stellar ghosts, born from stars not unlike our sun. They're small, dense spheres, no larger than Earth, yet containing masses comparable to entire stars. Their brilliance fades slowly over billions of years, cooling gradually until they become black dwarfs, cold, dark remnants that no longer shine. Though none have cooled that far yet. The universe isn't old enough. Andromeda is filled with countless white dwarfs, glowing softly like embers in the galactic night. More dramatic are the neutron stars. These form when massive stars collapse under their own gravity, compressing their cores into objects of unimaginable density. A teaspoon of neutron star matter would weigh billions of tons, heavier than a mountain. These remnants spin rapidly, sometimes hundreds of times each second, and their magnetic fields sweep beams of energy across the galaxy. To distant observers, they appear as pulsars, cosmic lighthouses flashing with perfect regularity. Among these remnants, magnetars stand out as the most extreme. Their magnetic fields are trillions of times stronger than Earth's, twisting and warping space around them. Occasionally, they unleash violent bursts of energy, explosions so powerful they can be detected across galaxies. For a brief moment, their brilliance rivals entire star systems, only to fall back into eerie stillness. Each of these stellar corpses carries a history. The heavy elements within them, carbon, oxygen, iron, were forged in the hearts of living stars. When those stars died, their remnants seeded the galaxy with the raw materials needed for planets, oceans, and life itself. And so these graveyards aren't places of endings alone, but origins as well. From their ashes, new worlds will form. To drift among them is to sense both loss and continuity. The light they once gave is gone, yet their presence lingers, quiet and unyielding. Andromeda holds billions of such remnants, scattered like ancient stones across the galactic landscape. Each one is a monument to the fleeting brilliance of a star, each a reminder of the cycles that govern the universe. If we could listen closely, perhaps we'd hear their faint voices, the rhythmic pulse of a neutron star, the quiet cooling of a white dwarf, the sudden cry of a magnetar flare. They're not silent at all, but speaking in the language of physics, whispering stories billions of years old. As we move on, leaving these stellar graveyards behind, we're reminded that death in the cosmos is never final. It's transformation, a handing down of light and matter to future generations of stars, planets, and perhaps life. Pulsars, cosmic clocks. Rotating neutron stars sweep space with lighthouse beams of energy. Their precision surpasses the finest clocks humanity has ever built. These remarkable remnants are neutron stars so dense that a single teaspoon of their matter outweighs entire mountains. Yet despite their compact size, they spin with astonishing speed, some rotating once every few seconds, others hundreds of times each second. With every turn, their magnetic fields funnel beams of radiation outward, sweeping across the galaxy like the beam of a cosmic lighthouse. When those beams intersect with Earth or any distant world, they appear as rhythmic pulses of light and energy, as regular as the ticking of a clock. Astronomers first discovered pulsars in the late 1960s, puzzled by their uncanny precision. At first, Their signals seem too regular, too perfect, leading some to wonder if they might be messages from intelligent civilizations. The idea quickly gave way to a deeper truth. These were natural clocks, crafted not by minds, but by physics itself. Even now, pulsars remain some of the most accurate timekeepers in the cosmos. Their signals so steady, they rival the finest atomic clocks humanity has created. To imagine a pulsar is to picture a sphere no larger than a city, spinning so rapidly that its surface moves at a significant fraction of the speed of light. The forces inside are unimaginable. Neutrons packed tightly together, gravity crushing with relentless strength. The magnetic fields generated by these spinning bodies are immense, capable of accelerating particles and unleashing powerful radio waves, X-rays, and even gamma rays into space. For any civilization that might one day navigate Andromeda, pulsars would serve as cosmic landmarks. Their pulses, precise and predictable, could be used to triangulate positions across light years. A galactic navigation system written into the fabric of space itself. Already, humanity has begun to dream of such uses. Our own Voyage spacecraft, drifting beyond the solar system, carries maps pointing back to Earth, using the distinctive signals of nearby pulsars, messages etched in the universal language of physics. And yet pulsars are more than practical tools. They're reminders of nature's extremes, of how beauty emerges from collapse. Once blazing stars have died, imploding into dense cores, yet they continue to speak through rhythm. Their steady ticking tells the story of time on cosmic scales, unchanging for millions of years. For a traveler drifting through Andromeda, their light would be both a guide and a comfort, a heartbeat echoing in the vast silence of interstellar space. As we drift away, their rhythmic flashes fade into the distance, still pulsing with unwavering regularity. They remind us that even in death, stars can shine as beacons, their voices carried across the galaxy. They're the clocks of the cosmos, keepers of time in a universe where nothing else remains constant. Magnetors, titans of magnetism. Magnetic fields, trillions of times stronger than Earth's, twist reality itself, releasing bursts of power so violent they could be felt across galaxies. These are magnetars, the rarest and most extreme children of collapsed stars. Born from supernova explosions, they begin life as neutron stars, but with one crucial difference. Their magnetic fields are unimaginably intense. To stand near one, even if such a thing were possible, would be to feel the very atoms of your body pulled apart, electrons stripped from nuclei by forces beyond comprehension. A magnetar isn't just a star, it's a distortion of reality, a cosmic engine of raw power. Only a few dozen magnetars have been discovered in our Milky Way, and Andromeda surely holds thousands more. Each one is an object of paradox, only about 20 kilometers across, yet containing more mass than our Sun, and wielding magnetic fields so strong that even light bends strangely in their presence. They're the ultimate extremes of physics, balanced on the edge of what the universe allows. Occasionally, magnetars unleash flares of energy, giant bursts of X-rays and gamma rays that race across space at the speed of light. These outbursts can release more energy in a single second than our Sun produces in hundreds of thousands of years. Astronomers on Earth have detected such flares from distant galaxies, flashes that briefly outshine everything around them. If a magnetar erupted too close to us, the results could be catastrophic. stripping atmospheres and sterilizing worlds. Thankfully, none lie within immediate danger. Yet despite their violence, magnetas are also strangely quiet most of the time. They spend long years in dormancy, their immense magnetic fields slowly decaying. During these phases, they might resemble ordinary neutron stars, pulsing faintly as they rotate. Then suddenly, the quiet breaks. An outburst tears free, shaking the surrounding space with a storm of radiation. For those who study them, magnetars are unpredictable, alternating between silence and fury like cosmic tempests. Their magnetic fields warp not only matter, but thought itself. Theoretical physics suggests that near a magnetar, the vacuum of space can behave strangely, splitting photons into pairs, bending light in ways no ordinary star could achieve. In such an environment, the very rules of nature blur. To witness one up close would be to glimpse physics at its most alien, where familiar laws dissolve into the unimaginable. Andromeda, with its trillion stars, must be home to countless realms shaped by magnetars, remnants of ancient suns that ended in violence and now linger as magnetic titans. They're beacons of both danger and wonder, their existence a reminder that the universe is filled with extremes far beyond what human intuition can easily grasp. As we drift onward, leaving behind the strange dominion of magnetars, the galaxy opens again into calmer seas of starlight. But the memory of them lingers. Compact stars barely the size of a city, yet powerful enough to shake galaxies. They're proof that in the quiet after death, some stars burn, not with light, but with invisible power that reshapes reality itself. Supernovae, cosmic fireworks. Here, massive stars explode with brilliance that rivals entire galaxies, scattering heavy elements, the seeds of planets and life. A supernova is one of the most spectacular events the universe can create. For a brief time, a single dying star can shine brighter than 1 trillion others combined, outshining the entire galaxy around it. The explosion is so powerful, it tears the star apart, flinging its outer layers into space at astonishing speeds. What remains is both an ending and a beginning, destruction that gives rise to creation. In Andromeda, where massive stars are plentiful, supernovae light up the spiral arms every few centuries. To those who might live in this galaxy, they'd appear as sudden, dazzling lights in the sky, stars that flare into brilliance, then fade into silence. For astronomers on Earth, even at a distance of 2.5 million light years, a supernova in Andromeda would appear so bright it could be seen during the day, rivaling the glow of the moon. But beyond their beauty lies their importance. Supernovae are factories of heavy elements. Inside their cores, stars spend their lives fusing lighter atoms into heavier ones, hydrogen into helium, helium into carbon, carbon into oxygen, and so on. Yet the heaviest elements, iron, gold, uranium, can only be forged in the final catastrophic seconds of a supernova's collapse. When the explosion scatters these elements across space, they seed future generations of stars and planets. Every atom of iron in our blood, every grain of calcium in our bones, was once created in such cosmic fireworks. The shockwaves from these explosions ripple outward, colliding with nearby clouds of gas. The impact compresses them, sparking the birth of new stars. In this way, supernovae don't only end lives, they ignite new beginnings. They're part of the endless cycle of the galaxy, where destruction and creation are woven together in a single process. Not all supernovae are the same. Some come from massive stars collapsing under their own gravity, leaving behind neutron stars or black holes. Others occur when white dwarfs in binary systems steal matter from companion stars, eventually igniting in runaway thermonuclear explosions. Each type leaves a distinct remnant, a nebula glowing with colorful filaments of gas, or a compact exotic object that challenges our understanding of physics. In Andromeda, remnants of ancient supernovae can still be found. Expanding shells of gas glow in red, green, and blue like delicate petals scattered across the galaxy. These nebulae are vast, spanning light years, and yet so thin they'd feel like a vacuum to us. They drift quietly now, but their shapes are living evidence of past fireworks, frozen snapshots of death and rebirth. To drift among them is to witness the galaxy's heartbeat, occasional bursts of brilliance that ripple across millions of years, sowing the ingredients for life into the cosmos. As we leave these cosmic fireworks behind, we carry a humbling realization. Every planet, every life form, every person listening to this story owes their existence to such explosions. We are, quite literally, the dust of ancient stars, scattered and reshaped by the brilliance of supernovae. Nebulae, celestial paintings. Vast clouds of gas stretch like brushstrokes across the galaxy, glowing in crimson, emerald, and sapphire. Celestial paintings born of death and rebirth. Nebulae are the canvases upon which the galaxy writes its story. Each one is both delicate and immense, spanning light years across yet so thin that much of their substance is emptier than the air on Earth. They're born from the remnants of dying stars, supernova explosions that scatter gas into the void, or from the gravitational collapse of vast hydrogen clouds preparing the cradle for new suns. In Andromeda, nebulae are scattered like jewels, decorating its spiral arms with luminous clouds that glow against the darkness. Their colors arise from the atoms within them. Hydrogen glows in shades of pink and crimson. Oxygen shines in emerald green. Sulfur radiates deep red. When ultraviolet light from nearby stars excites these gases, they shine, creating radiant shapes that resemble wings, veils, and tendrils. To our eyes, they appear as cosmic paintings. Yet every stroke of color is the mark of physics in motion. These glowing regions are both beautiful and functional. They're the incubators of stars, nurseries, where new generations begin. Some nebulae take the form of vast pillars and towers, sculpted by stellar winds and radiation. Dense knots of gas resist erosion, standing as dark silhouettes against glowing backdrops, like mountains against a twilight sky. Within these knots, stars continue to form, their light slowly carving tunnels through the clouds that once hid them. Over millions of years, the shapes shift, dissolve, and vanish, only for new nebulae to rise elsewhere. The artwork of the cosmos is never finished. It's always changing, always renewed. Others expand as delicate shells. These planetary nebulae are the final breaths of dying stars, thin layers of gas cast off in luminous rings and bubbles. They glow softly, fragile but enduring, visible for tens of thousands of years before fading into invisibility. Andromeda holds thousands of such nebulae, each one a memorial to a star that once burned steadily, now transformed into a white dwarf at its center. Still others are chaotic and colorful, supernova remnants. Their filaments twist outward like shattered glass, glowing in shifting hues as shockwaves plow into surrounding space. To drift near one would be to pass through threads of glowing gas, illuminated like stained glass in the vast cathedral of the galaxy. The beauty of nebulae isn't simply in their colors, but in what they represent. They embody the cycle of life and death at the grandest scale. From their gas and dust come new stars and planets, and from those, the building blocks of life itself. What seems like art is also the engine of creation, shaping the galaxy's future while preserving the memory of its past. As we drift away, the nebulae fade into distance, their colors blending back into the black of interstellar night. They remind us that the universe isn't only vast, but also expressive, painting itself with light, color, and motion. An artist working with the palette of eternity. Gravitational lensing. Stars and black holes bend light like glass, creating distorted arcs of distant galaxies, echoes of deeper realities. This bending of light is called gravitational lensing, a phenomenon predicted by Einstein's theory of general relativity. Space itself isn't flat but curved by mass. When light from a distant object passes near something massive, like a star, a cluster of galaxies, or a black hole, it follows the contours of that curvature. To us, the observer, the distant object appears stretched, magnified, or multiplied into ghostly arcs across the sky. In Andromeda, as in every galaxy, these natural lenses reveal hidden truths. A black hole, invisible on its own, might betray itself by the distorted ring of light it creates, called an Einstein ring. A cluster of stars might bend light from galaxies even farther away, allowing us to glimpse structures we could never otherwise see. The cosmos, through its gravity, becomes both the subject and the lens of its own observation. Imagine drifting near a massive star, watching the field of distant stars beyond it bend and shift. Patterns would curve as though the universe were being seen through rippling glass. In extreme cases, a single background star might appear as multiple images, scattered into arcs or halos. For astronomers, these distortions aren't distractions but tools. They allow us to map the invisible distribution of mass, including the elusive dark matter that makes up most of the universe's content. Gravitational lensing is a cosmic magnifying glass. Distant galaxies far too faint to observe directly become visible when their light is amplified by the mass of something in the foreground. Some of the most detailed images of early galaxies, the very first structures to form after the Big Bang, have been captured through this technique. Without lensing, they'd remain hidden, lost in the depths of time. Black holes provide the most dramatic lenses of all. Light curves so sharply near their event horizons that it can loop around them, allowing us to see the far side of an object from the front. To hover near such a region would be to witness the impossible. Stars smeared into rings, space twisted into kaleidoscopic patterns. It's not illusion, but the true path of light through curved space. Reality itself bent into art. In Andromeda, countless opportunities for lensing exist. Massive clusters of stars and dark matter weave distortions into the background fabric, creating arcs and echoes we can study from Earth. These silent effects reveal not only the presence of otherwise invisible objects, but also the shape and structure of space-time itself. To think of gravity not only as a force, but as a sculptor of vision is humbling. It shows us that even light, which seems the swiftest and freest of things, is bound to the fabric of space. And in that binding, beauty emerges, rings, arcs, and illusions that expand our understanding of what lies beyond. As we leave these invisible lenses behind, the galaxy resumes its normal shape, stars returning to their places. But we carry the knowledge that every line of light might hold hidden secrets, bent and shaped by the unseen hands of gravity. The quiet between stars. Even in crowded regions, most of space remains silent and still, dark oceans of emptiness surrounding islands of light. From a distance, galaxies appear dense, their spiral arms brimming with countless suns, layered like jeweled rivers. Yet when we move closer, we discover a very different truth. Stars, even in the busiest regions, are separated by vast gulfs of nothingness. The spaces between them are so large that if our sun were the size of a marble, the nearest star would be another marble placed hundreds of miles away. The galaxy is built less of stars than of emptiness, an ocean with scattered islands of fire. In these voids, silence reigns. There's no air to carry sound, no winds, no whispers. Only the faint hum of radiation drifts across the dark, a background echo left over from creation itself. It's a silence beyond human experience, deep, absolute, eternal. To drift here is to float in a stillness so complete that even time feels slowed, stretched thin by the absence of change. Yet emptiness isn't nothing. Scattered atoms of hydrogen drift through these spaces, thinly spread across light years. Dust grains float, small as motes of smoke, yet carrying the seeds of future stars. Magnetic fields thread invisibly across the void, guiding particles in faint, graceful arcs. Dark matter, unseen but immense, provides the structure within which all stars and galaxies are suspended. The quiet between the stars isn't a blank canvas, it's the stage upon which the universe is written. For travelers, this space would appear as endless night. The distances are so immense that light, racing at the fastest speed possible, can take years, centuries, or even millennia to cross them. To move between stars is to move between eras, stepping across the slow heartbeat of the galaxy. This quiet isn't lonely though, it's serene. It's the universe at rest, balanced between bursts of creation and collapse. Nebulae might glow at the edges, supernova remnants might shimmer in the distance, but in between lies stillness, a reminder that not all of the cosmos is fire and fury. Some of it is peace, and yet even here, the galaxy leaves its mark. Cosmic rays speed invisibly through the void, high-energy messengers from violent events far away. Photons from ancient stars pass silently, crossing billions of years before reaching an eye or an instrument. Gravity stretches across the emptiness, binding stars together though they never touch. The quiet between the stars isn't absence, but connection. A vast web linking everything in silence. As we drift through these dark oceans, we come to understand their beauty. Without emptiness, there'd be no perspective, no contrast, no sense of scale. The spaces between the stars make the stars themselves more brilliant, more meaningful. And so we continue, leaving behind this stillness, carrying with us the memory of peace, the quiet heartbeat of a galaxy that speaks just as much in silence as it does in light. The coming collision. The Milky Way and Andromeda are spiraling slowly toward each other, locked in a gravitational embrace that will one day merge them into one. Though separated now by 2.5 million light years, their fates are certain. Andromeda drifts toward us at a speed of over 100 kilometers per second, a silent motion across the void. To us, this movement is imperceptible. Night after night, the stars appear fixed, but given time, billions of years, the great spirals will meet, their arms entangling in a cosmic dance that has played out countless times before across the universe. This collision won't be violent in the way we imagine. Stars are too small and too widely spaced to strike one another directly. Instead, the galaxy's mutual gravity will stretch and distort them, pulling out long tidal tails of stars, gas, and dust. Spiral arms will twist into new shapes, flung outward like ribbons in slow motion. Clouds of gas will collide and compress, igniting brilliant bursts of star formation. The dark skies of both galaxies will be illuminated by newborn suns, glowing like fireworks in the aftermath of collision. For any civilizations alive to see it, the skies will transform. Where once a band of the Milky Way arched across the night, Andromeda's form will swell larger and brighter until it dominates the heavens. Over millions of years, its spiral arms will stretch, merge, and dissolve into ours, painting the sky with patterns of light no human eye has ever seen. The two galaxies, once separate, will become a single, immense elliptical giant filled with trillions of stars. The central black holes of both galaxies will also meet. For ages, they'll circle each other, spiraling inward as gravitational waves ripple through space. At last, they'll merge, becoming one even larger black hole, an event so powerful it will shake the fabric of space-time itself, sending out vibrations that could be detected billions of light years away. Though this sounds apocalyptic, for most stars and planets, the merger won't be destructive. Our solar system, if it still exists then, might simply be flung into a new orbit around the combined galaxy, or perhaps cast adrift into intergalactic space. The view from Earth, if Earth still endures, would be one of wonder, not catastrophe. Skies alive with spirals of light, glowing streams of stars, and the birth of a new galactic form. The Milky Way Andromeda collision isn't unique. All galaxies grow through mergers, and cosmic cannibalism is part of their evolution. Our two spirals are simply following a path set by gravity, one written billions of years ago when the universe was young. As we drift away, we carry with us the image of two giants moving closer. Their dance so slow, it spans epochs, yet so inevitable it feels timeless. The future holds their union, a reminder that even on the grandest scales, the universe is never still. It's always in motion, always becoming something new. Simulations of the merger. Astronomers have modeled the collision, spirals twisting, arms shredded, stars scattered. Yet life might still survive the chaos. Through supercomputers, we can watch the meeting of the Milky Way and Andromeda unfold across billions of years. The simulations play like slow-motion tapestries, galaxies approaching, merging, reshaping. At first, the two spirals drift nearer, graceful in their inevitability. As they overlap, long streams of stars are torn from their arms, stretching into ribbons that curve like silk across the darkness. The once distinct shapes dissolve into tangled knots, only to recombine into something entirely new, a massive elliptical galaxy, smooth and rounded, glowing with the combined light of trillions of stars. In these simulations, the process takes billions of years, Yet the imagery is immediate, breathtaking. Spirals pulled apart like threads. Star clusters scattered into wide arcs. Clouds of gas smashing together, triggering bursts of starbirth so intense that entire regions light up like cosmic fireworks. It's a vision of destruction, but also of creation, where the end of familiar forms gives rise to new structures and possibilities. For stars and their planets, survival depends on chance and distance. While the odds of two stars colliding are vanishingly small, the gravitational tides of merging galaxies can alter orbits dramatically. Solar systems might be hurled into new paths, their skies transformed as constellations dissolve and reform. Some might be cast into the outer reaches of the new galaxy, drifting in isolation. Others might be drawn inward, circling closer to the central black hole that emerges from the merger. What about Earth? Simulations suggest that if our planet still exists billions of years from now, it might survive the encounter largely intact. The sun won't collide with another star. Instead, the greatest change would be in the sky itself. For future observers, Andromeda's light will swell across the heavens, stretching from horizon to horizon, its arms filling the night with rivers of brilliance. Over time, those spirals will blur, replaced by the smooth glow of the new galaxy's vast body. To stand under such a sky would be to witness an unimaginable transformation, a living painting written in light. These simulations remind us of the paradox of cosmic violence. What looks like chaos on one scale creates order on another. Galaxies don't merely end when they collide. They become something greater, larger, and often richer in stars. For life, it might be upheaval. For the universe, it's simply evolution, the endless recycling of matter and form. In the silence of Andromeda's future, no one moment defines the collision. It's not a single explosion, but a slow unfolding, a dance of gravity written over eons. The computer models give us a glimpse into that distant destiny, showing not an apocalypse, but a transformation. As we drift away from these imagined futures, we're left with awe. The universe isn't static, but alive with change. And in that change, there's beauty, a promise that even endings are beginnings, and that survival can emerge even from chaos. Are we alone? Could beings in Andromeda gaze back across the void at us, wondering the same questions? The thought lingers in the silence. Andromeda holds more than 1 trillion stars, each one a possible sun, each surrounded by its own retinue of planets and moons. Statistically, the odds suggest that life in some form might have taken root there. Perhaps in the light of red dwarfs, alien forests stretched beneath perpetual twilight. Perhaps in methane seas, bioluminescent creatures rise toward the surface, glowing faintly under alien skies. Or perhaps entire civilizations have already flourished and fallen, their histories written in languages and forms we can scarcely imagine. The silence of space tempts us to wonder if we're alone. Yet silence doesn't mean emptiness. Light takes millions of years to cross the distance between us and Andromeda. Any signal sent from there would arrive today, carrying echoes from long before humanity existed. If intelligent life does dwell among its stars, their stories are written in a time so far removed from ours that communication might always remain impossible. And still, the thought of their presence lingers, whispers carried on starlight. What would such civilizations be like? Some might resemble us in their curiosity, gazing outward, searching for companions in the void. Others might live in forms beyond recognition, intelligence spread across networks of machines or organisms that perceive reality through senses we don't possess. Some might dwell beneath seas of ice, never knowing the stars, their awareness confined to the glow of geothermal vents. Others might thrive on super-Earths under heavier skies and stronger gravities, their bodies shaped by pressures alien to us. And if they do exist, do they also wonder? Do they chart the sky, see our Milky Way shining as a faint band, and ask if minds live there too? Do they dream of crossing the void, or do they accept the silence as the natural order of things? The vastness of Andromeda reminds us that the cosmos is filled with possibility. 1 trillion stars means 1 trillion chances. And if civilizations have arisen, perhaps they've already faced challenges we can't yet imagine. Stellar flares that threaten their survival, galactic collisions that reshape their skies, or the long patience required to endure the ages of a universe still unfolding. For now, we can only speculate. The evidence of alien civilizations, if it exists, is hidden in the faintest signals, the subtlest patterns of light. But imagination itself is a kind of connection. To dream of them is to bridge the distance, if only in thought. As we drift onward, the question remains unanswered, hanging softly in the stillness. Are we alone? Or are there others staring back from Andromeda, just as curious, just as awed, just as humbled by the infinite? The silence of space doesn't answer. But the question itself is part of the wonder, a reminder that the universe is vast enough for both solitude and possibility. Dark matter, the invisible skeleton. Though unseen, dark matter shapes Andromeda's every motion, holding it together, guiding the paths of stars like a hidden skeleton. Without it, the galaxy would fly apart. The stars in Andromeda's spiral arms spin far faster than visible matter alone could explain. By the laws of gravity, much of the galaxy should simply scatter into space, its stars flung outward like sparks from a fire. Our journey through Andromeda is coming to a close now. We started by leaving Earth behind, that fragile blue dot suspended in darkness. We drifted past frozen frontiers, through the silence between stars, and into the luminous heart of a galaxy 2.5 million light years away. We saw stars being born in glowing nebulae, and others ending in brilliant supernovae. We imagined planets of endless variety, moons of alien beauty, and maybe even civilizations looking outward with the same curiosity we feel. We explored invisible forces, dark matter binding galaxies together, dark energy slowly pulling them apart. And we watched as Andromeda and the Milky Way spiral toward their destined embrace, billions of years from now. In the end, the galaxy fades into the distance, leaving us in stillness, wrapped in the silence of space. And in that silence, there's perspective, a reminder that though we're small, we're part of something vast, ancient, and magnificent. As you drift towards sleep tonight, hold on to this thought. The atoms in your body were born in the hearts of stars. You're not separate from the cosmos. You're woven into its very fabric. To look outward is also to look inward, to see both wonder and belonging. May you carry that sense of connection with you. Earth, fragile as it is home. Life, rare as it may be, is a gift. And in the stillness of night, we're all part of a universe that's always changing, always becoming, always unfolding in beauty. Now let the stars fade, let the galaxy soften, and let sleep carry you gently, as if borne on cosmic tides into rest. Good night.